Hello, this is Liz Presley with Tutor of Dragons. Today we're going to talk about volume using your integral from calculus. When you are looking for volume, there are three things that you need to know. You need to know, first of all, are you going to use top minus bottom? Are your equations in that format, or are they left and right? You also need to know if you are perpendicular to which axis. If you are perpendicular to the y-axis, you will use a dy, meaning you use x equal equations. If you are perpendicular to the x-axis, you're going to have a dx, which means that you are using y equations. If you are using a dy, you're going to be doing your right equation minus your left equation. If you're using dx, you're going to do top minus bottom. Okay? Now you also need to know your shape, and most calculus teachers will tell you to memorize these. They will not be given to you. Your square is a side squared. Your semicircle is pi over 8 side squared. Your rectangle is your base squared, which is essentially your side, times the height, okay? And your height is some multiplier of the base. For instance, they may say, I want a rectangle that is 3 times the height of my base, so it would be b squared times 3. Your isosceles right triangle, where your side is the base, is 1/2 side squared. If it is the hypotenuse, forgot that p there, as the base, then it is 1/4 side squared. And if it's an equilateral triangle, then it's root 3 over 4 side squared. Okay, so this is the basics of what you need to know before you even get to the calculator. Now I'm going to use y equals negative x squared plus 4 and y equals 2x plus 1. If I were to quickly graph it, it looks something like this, okay? So clearly that is a top minus bottom. So I'm going to be using this dx equation. I'm going to try to do it as a rectangle. I want it to be perpendicular to the x-axis. So my equation would be integral top minus bottom, my intersection x on the left, x on the right, and my multiplier, my rectangle, was going to be 3 times this height, my side, top minus bottom, squared, dx. Okay, so for the sake of time, I've already plugged these equations in. I know that that's the top and that's the bottom. And if I graph it, sure enough, my actual graph looks similar to my hand-drawn graph here. I know that my intersection point here, if I were to do second intersect, this intersection point here is -3, -5, and this intersection is 1, 3. I'm looking at the x values. So my actual integral would be 3, math 9. My x on the left, as I already said, is -3. My x on the right is 1. Now, I need to square this side in here. So you need to make sure that you add an extra set of parentheses. Then you're going to do alpha trace y1 minus alpha trace y2, close your parentheses and square it, dx. And there's my volume, okay? Now, let's say I wanted to do it with an equilateral triangle. So all you're doing here is you're rechanging that 3 out in front to a multiplier of root 3 over 4. So square root 3, get out of that, divide by 4. You can do it this way, or you can get really fancy and do alpha y equals or alpha x and do your square root of 3 over 4. Now, the thing is you can only use this version if they're asking you for something not exact. If they're asking you for something exact, you don't want to put that in your equation. Okay, and then it would be, again, math 9, -3, 2, 1. New set of parentheses, alpha trace y1 minus alpha trace y2 squared dx. There it is. So notice with an isosceles right triangle, as opposed to it being like this, where I'm doing triangles over and over again, it's much different, a much smaller area than if I were trying to make rectangles over this. Okay, that's it for volume using your calculator and an integral for calculus. Thank you, and if you like this video, please subscribe to Tutor of Dragons for more upcoming features.